A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
Have you ever been on a video call on your phone and realized that the background replacement is actually better than what you get on your high-end desktop? It is kind of wild that a device that fits in your pocket can handle pixel-perfect segmentation, while your laptop starts sounding like it is preparing for takeoff just to blur a messy room. Today is March 25th, 2026, and we are looking at a prompt from Daniel about exactly that. Specifically, we are diving into the shift toward on-device edge AI for real-time video and why there is such a massive gap between mobile hardware and desktop Linux.
It is a fascinating technical divide, Corn. My name is Herman Poppleberry, and I have been digging into the underlying shift we are seeing right now in early 26. We have moved past the era of feature-based AI, where a model was just looking for a face or a hand, and into what I would call foundational edge AI. The magic you are seeing in things like WhatsApp or even the latest Instagram filters is not just a clever trick anymore. It is a fundamental architectural change in how the hardware and software talk to each other. We are talking about a paradigm where the edge is no longer just a peripheral. It is the primary engine for semantic understanding.
I remember when background removal meant you had to sit perfectly still or half your ear would disappear into the digital void. Now you can have confetti flying around your head or replace your entire living room with a beach, and it tracks every single stray hair. Daniel is asking how we got here without burning our hands on the phone battery. Is this all happening on the device? Or is there a massive server farm somewhere doing the heavy lifting?
It is almost entirely local now, which is the most impressive part. There is a twofold reason for that. First, the economic reality. When you have a service like WhatsApp handling over 2 billion calls every single day, trying to process that video on a server would be a financial nightmare. You would need an unimaginable amount of compute power. But the second, and perhaps more important reason for the users, is privacy. We are seeing a move toward what is called S-frame end-to-end encryption. The video has to be transformed on your device before it gets encrypted and sent over the wire. If the server were doing the background replacement, the service provider would have to see your unmasked, unblurred video feed, which breaks the whole promise of end-to-end encryption.
So my phone is basically a mini VFX studio. How does it actually see the difference between my head and the wall behind me without the green screen? I know we have talked about segmentation before, but this feels like a different level of precision. It feels like the phone actually understands what a person is versus what a chair is.
That is exactly what is happening. The industry has really rallied around the Segment Anything Model 2, or SAM2 framework. In the older days, you would train a model specifically to recognize a person. It was very rigid. If you held up a cat or a weirdly shaped lamp, the model would get confused. SAM2 treats segmentation more like an interactive negotiation with memory. It uses a mechanism that allows for temporal coherence across frames. Instead of looking at every frame as a brand new image, it remembers the mask it created for the previous frame and uses that to predict the next one. This memory bank allows it to track complex boundaries, like individual hair strands or the edge of a coffee mug, with incredible stability. Even if you move quickly, the model is not starting from scratch. It is just updating its understanding based on the previous state.
That sounds like a lot of math to do 30 times a second. You mentioned foundational edge AI. What is the actual library doing the work? Because I doubt every app developer is writing their own custom computer vision stack from scratch. There has to be a standard, right?
Most of the world is running on Google MediaPipe. It is the dominant lightweight library for this kind of work. Specifically, their selfie segmentation model is the workhorse here. It uses a modified MobileNet v3 backbone. To give you a sense of the scale, the detector part of that model has about 815,000 parameters, while the landmarking system uses about 3.36 million parameters. That sounds like a lot, But in the world of AI, that is incredibly lean. It is optimized specifically to run on what we call the NPU, or Neural Processing Unit.
Ah, the NPU. That is your favorite topic. You have been waiting for the NPU to become the star of the show for years, and it finally happened. But why is it that my phone has this specialized engine that works perfectly? But if I try to do the same thing on my Linux desktop, I am stuck using some fragmented OBS plugin that makes my CPU temperature spike to 90 degrees. It feels like we are living in two different technological eras, depending on which screen we are looking at.
That is the NPU gap, and it is the heart of Daniel's question about the platform discrepancy. Mobile manufacturers like Qualcomm and Apple have been building for a two-engine hardware philosophy for years. On a Snapdragon 8 Gen 5, which is what we are seeing in the top Android phones right now, you have an NPU capable of over 50 TOPS or tera operations per second. That NPU is designed to be always on and extremely power efficient. It handles the camera effects while the main CPU and GPU can stay relatively idle. On the desktop side, particularly in the Linux ecosystem, we are just now catching up to that level of integration.
It is funny because on paper, my desktop is way more powerful than my phone. It has a massive power supply, a huge GPU, and enough fans to hover. Yet, for this specific task, it feels like a dinosaur. Is it just a driver issue, or is the hardware actually missing on the desktop side?
It is a bit of both. Until very recently, desktop processors did not really have a standardized NPU. Intel and AMD have only recently started shipping chips with serious AI acceleration like the Core Ultra and Ryzen AI lines. But even with the hardware present, the software stack on Linux has been a mess of fragmentation. If you want to use camera effects on Android, the app just hooks into the Android camera, to API. The operating system handles the handoff to the NPU drivers. On Linux, you are often dealing with v4L2 loopback, which is a kernel module that creates virtual video devices. It is a workaround, not a native path. Most of these Linux tools end up falling back to the CPU because they cannot easily talk to the NPU or the GPU without a lot of manual configuration.
So while the Android user is just tapping a button to turn into a potato during a meeting, the Linux user is in the terminal trying to recompile a kernel module just to blur their laundry. That sounds about right for the Linux experience. But you said things are changing this year. We are in March of 2026 now. Are we seeing the light at the end of the tunnel?
They really are. We just had the release of Intel OpenVINO 2026.0 in February. That was a huge milestone because it introduced much better NPU handling for those Core Ultra systems. It allows for ahead-of-time compilation on the device without needing specific OEM drivers for every single laptop. And even more exciting for the open source crowd is the upcoming Linux Kernel 7.1, which we expect in April. It is finally going to include the AMD XDNA driver. This is a big deal because it will expose real-time NPU busy metrics and power monitoring for AMD Ryzen AI chips to the rest of the system. For the first time, a Linux app will be able to see exactly how much work the NPU is doing, just like we see with CPU usage today.
I love the idea of an NPU busy metric. I can finally see my computer being lazy in a whole new dimension. But does this actually solve the real-time problem? If I am on a call in 2026, I do not want a 300 millisecond delay. That is enough to make the conversation feel awkward and disjointed. You start talking over each other because the video is lagging behind the audio.
That sub 300 millisecond latency is the gold standard, and it is why local processing is the only way forward. Even with the fastest fiber connection, sending raw video to a server, processing it with SAM2, and sending it back adds too much round-trip time. By moving the foundational model to the edge, you eliminate the network jitter. The transition we are seeing right now is that the model is becoming part of the hardware abstraction layer. In the future, you won't even think of background replacement as an app feature. It will just be a capability of the camera stream itself.
It is like how we stopped thinking about autofocus as a software feature and just expected the camera to do it. I guess the same thing is happening with semantic understanding. The camera just knows what is a person and what is a chair. But I have to ask, with all this local power, are we seeing any cool creative uses for it? Or is it just for hiding our messy offices?
WhatsApp actually did something really interesting for the New Year's celebrations earlier this year. They had these festive effects like fireworks and confetti that were not just static overlays. Because the phone's NPU could do real-time segmentation and depth estimation, the confetti would actually bounce off your shoulders and head. It understood the geometry of the person in the frame. That requires a level of compute that would have been impossible on a mobile device just a few years ago. It shows that we are moving toward a world where the camera is not just capturing reality, but interpreting it in 3 dimensions in real time.
That is cool, but also a little creepy. If my phone understands the geometry of my shoulders well enough to bounce digital confetti off them, it knows a lot about my physical space. Which brings us back to that privacy point. If this were happening in the cloud, Meta or Google or whoever would basically have a 3-dimensional map of my room.
And that is why the push for local-first AI is so vital. It is a rare win where the economic incentives of the companies saving money on server costs actually align with the privacy interests of the users. By keeping the pixel-level transformation on the device, the service provider can maintain their end-to-end encryption promises while still offering these high-end features. We actually touched on this shift back in episode 1094 when we talked about why AI is moving back to the processor. We are seeing the hardware catch up to the software's ambition.
I remember that. We were talking about the CPU first era, but it feels like the NPU has sort of jumped the line. It is not just about general processing anymore. It is about these very specific high bandwidth tasks. If you are a developer looking at this landscape right now, what is the move? Do you keep building these CPU-bound plugins for desktop, or do you have to start learning these NPU native APIs?
If you are still relying on the CPU for real-time video, you are basically building on borrowed time. The thermal throttling alone will kill your user experience. Developers really need to look toward NPU native APIs like OpenVINO on Intel or the Qualcomm AI Hub for mobile. The challenge for the desktop side, especially Linux, is going to be standardization. On mobile, the OS acts as the gatekeeper and the translator. On Linux, we are still waiting for a unified way to talk to these different NPU architectures without writing 5 different versions of the same code.
It feels like the desktop is once again the underdog, which is a weird place for it to be considering it has more raw power. But I guess that is the price of a more open, fragmented ecosystem. You do not get that tight vertical integration you see on an iPhone or a high-end Galaxy device.
It is a trade-off, but there are people working to bridge that gap. I have been following the work of Tomeo Vizoso, who is a very prominent open-source developer. He has been working on reverse-engineered NPU drivers for a while now. He announced late last year that he is planning to launch 2 new drivers in 2026 that could finally bring some of that mobile-style acceleration to more generic Linux hardware. He is kind of the canary in the coal mine for open-source NPU support. If people like him can make it work, we might see the Linux desktop finally catch up to the phone in terms of seamless AI effects.
So there is hope for the Linux crowd yet. They might eventually be able to have digital confetti bounce off their shoulders without their laptop melting through the desk. I think the big takeaway from me here is that we are witnessing the death of the green screen, not just in Hollywood, but in everyday life. The computer is getting smart enough to understand context without needing a physical color key.
That is a great way to put it. We are moving from feature-based tricks to foundational understanding. And for anyone listening who is thinking about their next computer upgrade, I think the metric you need to start looking at is not just gigahertz or core count, but NPU tops. If you want to be able to run these real-time models locally, that is where the bottleneck is going to be. We talked about this in episode 633, The Memory Wars and the Future of Local Agents. The hardware requirements for these autonomous workflows are skyrocketing, and the NPU is the only way to meet them without killing your battery life or your thermals.
It is a brave new world of terror operations per second. I am still just trying to get my camera to stop focusing on the plant behind me instead of my face, but I guess I should aim higher. Maybe I will get one of those new Ryzen AI chips and see if I can get some fireworks going.
Just make sure you are running kernel 7.1 if you want to see those busy metrics. It is going to be a fun year for hardware nerds.
Well, I think that covers the mystery of the background magic. It is local, it is foundational, and it is coming for your desktop sooner or later. Big thanks, as always, to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes. And a huge thank you to Modal for providing the GPU credits that power this show. It is fitting that we are talking about the edge, but we still need that heavy-duty cloud compute to get these episodes out to you.
If you enjoyed this dive into the NPU gap, we would love it if you could leave us a review on your podcast app. It really does help other people find the show.
You can also find us at myweirdprompts.com for the full archive and all the ways to subscribe. This has been My Weird Prompts. We will catch you in the next one.
See you then.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts.